This is Tarun. I'm here to give presentation on assignment 4, gyroscope and accelerometer sensing and filter. Now let's take a look at the objective of the assignment: to compute body movements via gyrometer and accelerometer sensor, and to apply Kalman filter design for state estimation. For this assignment, you have been provided with the following hardware: Intel Galileo Gen 1 board and the MPO 6050, which is a 6-axis gyrometer and accelerometer. That means 3-axis gyrometer and 3-axis accelerometer. And we have been given Unity TCP control software and to emulate the orientation of the gyrometer. This is your MPO 6050 6-axis gyrometer and accelerometer. It consists of 8 pins starting with VCC, ground, SCL, SDA, which are used for I2C communication. Then we have got XDA and SCL, which are used for collaborating with any external hardware like magnetometer. But since we are not using any such device in our application, these pins will be left unconnected, and AD0 will be connected to ground and INT0 for receiving interrupt signals. Uh, VCC on the MPO 6050 is connected to 3.3 supply. Ground on MPO 6050 is connected to ground. SCL is connected to SCL on Galileo. SDA is connected to SDA on Galileo. AD0 is connected to ground and INT. Interrupt pin is connected to IO pin 3. MPO 6050 initializing the following register. We need to set the slave register to 0x68, as my AD0 pin is connected to ground. If AD0 pin is connected to high, then we should connect it to 0x69 instead of 0x68. Then power management 1 is the register 0x6b should be set to 0x00, that is no sleep mode, from the previous value of 0x40, which that is a sleep mode. The sampling rate should be set to 200 Hz as mentioned in our assignment. For that, the sampling register should be set to 0x27. Our assignment requires to read the gyrometer and accelerometer reading only when they are ready, so the interrupt enable pin is should be set to 0x01. This is a Unity TCP control software. It accepts the angular velocity values. Here we need to enter the IP address of the host country computer on which the TCP is running. Now let me take this opportunity to explain the whole working of my program. This is a flowchart of my program. Here the program starts. That is from the main. Then opening of the I2C device. Here I am opening the I2C device. Then calibrating the gyrometer values. Here I am calculating the gyrometer values. Then getting the gyroscope and accelerometer data. Here I am getting the gyroscope and accelerometer data, subtracting the raw values of gyroscope from the gyroscope offset, which I have calculated in calibrate gyro. Initializing the GPIO and MPU 6050 registers. Here I am setting the appropriate GPIO pin. Here I am initializing the save 0x060. Then power management 1 to 0x00 and sampling rate to 0x07, RA enabled to 0x01. Then I'm sending it to Kalman filter. I'm sending it to Kalman filter. This is my Kalman filter for getting the angle X, and this is my Kalman filter for getting the angle Y. And from that I'm calculating the roll and pitch from here by this formula. Then I'm sending the data through the socket. In the main, I've initialized the socket. Port number is 9999. This connects to the socket, and then sending it to Unity display. I'm sending from this function send the socket send Kalman to Unity display. Here I'm getting the difference from the Kalman previous values and the present values, and I'm then sending it to the display. Let me now run the application to demonstrate the output of the program. This I'm turning in the x-axis, negative x-axis. Now I'm moving the gyroscope in negative y-axis. I'm moving in the positive y-axis. And now I'm turning the gyroscope in the z direction. Thanks for watching. I hope you like it.